Questions 21 through 25 on the 2013 Grade 8 Gauss Math Contest. An arithmetic sequence is a sequence in which each term after the first is obtained by adding a constant to the previous term. For example, 2, 4, 6, 8, 1, 4, 7, 10 are arithmetic sequences. In the grid shown, the numbers in each row must form an arithmetic sequence, and the numbers in each column must form an arithmetic sequence. The value of x is. A few steps to doing this question, and we'll go in order. First, let's concentrate on that column. All arithmetic sequences are of the form a plus d, a plus 2d, and so on, a plus 3d. You get the point. Now, a is the first term, and d is the common difference. So, for example, in this one, the first term is 5. The next one is this guy, I don't know. The next one is this guy, I don't know. But this guy is this one, a plus 3d. So immediately, I know from this equation right here that a plus 3d is equal to 23. But I also know that a is 5. So that means 5 plus 3d is 23. So that means 3d is 18, and therefore d is equal to 6. So I can figure out this guy and this guy. So a plus d would be 5 plus 6, correct? So that's 11. Put that here. A plus 2d will be 5 plus 2 times 6, which is 12. So that's going to be 17. So there we go. I just figured out that column. Now I'm going to do the exact same thing, but on that row. So pretty much we have to do, I think that we might have to do this, let me think, 1, 2, 3, 4 times to get this x. If there's a shorter way, I'm trying to think, is there a shorter way? There probably is, right? Well, I just can't see it, but that's okay. I mean, if you guys find a shorter way, that more power to you. And the way I'm doing it is perfectly legit, and it probably explains it a little bit better. Okay, so now let's start with this row. In that row, in the exact same way, we're going to talk about these guys. So again, now keep in mind, these A's and these D's are not going to be the same throughout. They're different sequences. They're not like every single A equals the same, every single D. So instead of using A's and D's, I'll start using different letters, not to confuse you, but just to illustrate that they're not all the same. So it'll be like K, K plus D, K plus 2D, K plus 3D. Okay? This row. So the first is 11, right? And the last is 12, 1, 1. Okay. That means that K plus 3D is equal to 1, 2, 1, 1. And in the exact same way, I can substitute that fact that K is 11. So 11 plus 3D is 1, 2, 1, 1. And therefore 3D is 1200. And therefore D is 400. So this guy is K plus D, which it would be 411. And this is K plus 2D, which is going to be K plus 2D. So 811. Right? Yeah, so that means, here you go. Put that 411 and 811 in there. And we really didn't need to figure this one out. I just doing it for the sake of, being complete. Okay, so we're getting there. And I think we have to do this a couple more times. So the next one I'm going to concentrate on is this one here. And the reason is because I have to have at least 2 terms that are present in order to figure out the A and the D. See, here it's attempting to go straight to there, but I don't have 2. I only have 1. Okay, let's concentrate on that row. And don't get confused by the fact I'm going to use A and A plus D. They don't equal the same as up here, but I'm just using the same letters. I just don't want to create any confusion, or, too many letters creates confusion. Just remember that it's an arithmetic sequence. So the first one is actually up here, and I don't know what that is, so this one I don't know. But A plus D is 811, and A plus 2D is 1013, this column right here. Okay, I can use this and this to figure out A and D. If A plus D is equal to 811, and a plus 2d is equal to 1013. I can subtract them, and when I subtract them, I get d is equal to 1013 minus 811, and that means d is equal to 202. And then substituting back into there, I get a is equal to 609 basically. Yeah. So all I really need to figure out is this guy here. So I'll do that. So a plus 3d is going to be 609 plus 3 times 202. And that is going to give me a value of 1215. So there we go. 1215 goes here. 1215. Okay, we are now in the last step. And that last step is going to basically figure out our x. And I think that last step is going to involve a few things that we already know. I don't think I need much space, so I'll just do it up here. Again, it's going to be a plus d, a plus 2d like that, right? Well, a is 23 in this row. X is our a plus d, and 1215 is our a plus 2d. Okay, let's see here. So a plus 2d is 1215, and then a is 23. So I can easily solve for d. When I do, I get 2d is equal to 1215 minus 23, which is 1192, and then d is equal to 596. And therefore, finally, x, which is a plus d, is 23 plus d, which is 23 plus 596. And that is 619. And that's it. 619 is x. So with a little bit of algebra here, you're able to get the correct answer. So number 21, the answer is B. In right-angled isosceles triangle FGH, FH is root 8. And the arc FH is part of a circumference of a circle with center G and radius GH. As shown, the area of the shaded region is. Okay. This is a very standard question, appears on math contests a lot. So let's talk about this. The area of the shaded region would basically be 1/4 of the circle. Now you say, well, how do you know it's 1/4? Because of that symbol right there. That symbol represents 90 degrees. And 90 degrees is 1/4 of a circle, because the whole circle all the way around is 360. So it's 1/4 of a circle, this entire sector right there. So an area of a circle is pi r squared, and we have to take 1/4 of it. But we don't want the whole thing, we just want the area of the shaded region. So from that whole thing, we subtract this triangle. So you subtract from it triangle FGH, and the area of that triangle will be 1/2 base times height, which in our case would be GH for the base and FG for the height. Okay, so that's basically how we're going to do this. Well, let's label this R, radius, and therefore that's R, right? That's GH is representing the radius, and so is GF, or FG, whatever. So put that in there, pi r squared over 4 minus 1/2 GH is R, and FG is also R, so it's R squared. So the only thing we need to do is figure out R, and we're set. Well, how do we figure out R? Using the Pythagorean theorem right there. R squared plus R squared is equal to root 8 squared. So that means 2R squared is equal to 8, and therefore R squared is equal to 4. R is equal to 2. So we have pi 2 squared over 4 minus 1/2 2 squared. This is going to be pi, and this is 4 divided by 2, which is just 2. So there you go. Area of the shaded region is pi minus 2. So number 22, the answer is A. Greg, Charlize, and Azara run at different but constant speeds. Each pair run a race on a track that measured 100 meters from start to finish. In the first race, when Azara crossed the finish line, Charlize was 20 meters behind. In the second race, when Charlize crossed the finish line, Greg was 10 meters behind. In the third race, when Azara crossed the finish line, how many meters was Greg behind? Okay. Well, let's talk about this. Let's just make the track that it was a straight race from start to finish. Most tracks are in the shape of an oval, but that's okay. So we got race number 1, race number 2, and race number 3. So in the first race, when this is the finish line, who wins here? In the first race, Azara crossed the finish line first, and Charlize is 20 meters behind. So Charlize is approximately here, and that's 20. And then in the same kind of scenario, second race, Charlize crosses the finish line, and who's second? Greg is now here. He's second, and he's 10 meters behind. And in the last race, Azara crosses the finish line, and Greg is the person that we have to figure out where is Greg. So Greg is a certain amount of distance behind. Okay, here we go. So throughout this question, we're going to use the formula speed is equal to distance over time, or any variation of this formula according to what you want. So for example, time is equal to distance over speed is another variation of that formula. And that's what we're going to use, this guy right here. So in the first race, the time that it takes Azara to get to the finish line is the same amount of time that it takes Charlize to get to that point. At that point, their times are the same. Distances obviously are different. That's why they're 20 meters apart. And their speeds are obviously different. That's why Azara was able to finish faster. So both of their speeds are equal. Now both of their times are equal. Times are equal. So we're going to use this. So time is equal to distance over speed, right? So for Azara, that time is her distance, which is the full 100 meters, over her speed. And that's going to be the same as the time for Charlize. And her time is d over s, but her d is 80 because it's 20 meters less, right? She didn't complete the race yet. And her speed we'll call sc. All right. In the second one, exact same scenario, that Charlize is now finished the race, so her speed is 100, or her time rather, 100 over sc, and it's equal, because this represents time, is equal to the time that it took Greg to get there, and his time is going to be d over s, which is 90 because he's 10 meters from the finish line, so he only ran 90 over s of g. And then the last one in the very same way will be 100 over the s of a is equal to, this time we don't know. We don't know what this is, so it's going to be 100 minus x, actually, right? Because that's how we figure out the distance from the start to that point. And then, of course, the speed is just sg. So what I want to do, my goal is to get SA in terms of SG. I can plug it in, the SG's cancel, and then I can calculate X. Okay, going to use these two to do that. So from the first one, I get 8 SA is equal to 10 SC, right? I just divided through by 10. And then from the next guy, I get 9 SC is equal to 10 SG, correct? So I guess I can plug this guy into this guy, this one into this one. So I'll isolate for SC, and I get 8 over 10 SA, and then put that here. So that would be 9 times SC, which is 8 times SA over 10 is 10 SG. And therefore SA is going to be 10 times 10, which is 100, over 9 times 8. SA is going to be equal to that SG. Okay, perfect. Now I substitute that into there. So I got 100 over 100 over, what's that, 72, 9 times 8? 72 SG is equal to 100 minus X SG. Invert and multiply, or cross multiply actually. 100 SG is equal to 100 over 72 SG times 100 minus X. And then the hundreds cancel, and so do the SGs, interestingly. So all I have left with is 1 is equal to 100 minus X over 72. And therefore 72 is equal to 100 minus X. and therefore x is equal to 28. So that answers my question. Basically, what that means is the last sentence. In the third race, when Azara crossed the finish line, how many meters was Greg behind? He was 28 meters behind. So number 23, the answer is C. In any triangle, the length of the longest side is less than half of the perimeter. All of the triangles with perimeter 57 and an integer side lengths x, y, z such that x is less than y less than z are constructed. How many such triangles are there? We have a few rules to follow. I'll put those rules here on the side. The first thing, of course, very important, is that these sides are in this kind of relationship. X is less than y, y is less than z. And then the perimeter, of course, is the sum of those is 57. And another thing they told me is that the longest side is less than half the perimeter. So the longest side for us is z, and it's less than half of the perimeter. The perimeter is 57, so z is less than 57 over 2. 57 over 2 is what, 28.5? So z is less than 28.5, but z is an integer, so z must be either equal to or less than 28. Okay, so these are some very important rules that we are going to have to abide by when creating these triangles. So here we go. The first one I'm going to do is, let's see, where do I want to start here? Oh, let's just start with z equals 28 and just keep going down. Might as well make it easy. So let's look at the first one, which is when z is equal to 28. When z is equal to 28, that means that since x plus y plus z is 57, x plus y plus z is 57. If z is 28, plug that in, and we therefore get that x plus y must be equal to 57 minus 28, which is 29. So we have to create a table where z is 28, but x plus y is 29, and we have to make sure that they are in that inequality. So here is my first table. This satisfies everything. That z is 28 here. X plus y is 29. And that's pretty much it. And then the rest of the values for x and y I've put here. And as you can see, those are the values. And there's a total of 13 of them. So I'll put 13 out here. Now, these values all satisfy the fact that x minus y, or x is less than y, and y is less than z. Now you might say, well, you skipped over a 1. How about x equals 1? Why didn't you put x equals 1 in there? Well, because if x is 1 and x plus y is 29, then y would be 28. And you can't have y equals to 28 because z equals 28, and y has to be less than z, right? According to this inequality. So I have to abide by a certain set of rules here. The first rule, of course, is this one, then this one, and then now this one. Once you subtract z equals 28 from the perimeter, x plus y is 29. So I really wanted to, ensure that you understand how this table was created. Okay? And when you did, you got 13 possible sets for x, y, and z. Okay, now we move on to the next set. The next set is when z is 27. We're going down, right? We're going down from 28. Now when z is 27, and then you plug z into this equation right here, you get x plus y is equal to 30. So again, exact same thing. We have to make a table with values for x and y, abiding by these three rules. And when you do, you get this table right here. And that table gives me 11 additional values. All right, let's move on to the next one. The next one is z is equal to 26. Now x plus y will be equal to 31. And again, same thing. We have to ensure that x is less than y and all that stuff. And when we make that table, we get this scenarios, and that gives me an additional 10. Now let's keep going. Z equals 25. This times x plus y is 32. And again, I make the table, and this gives me 8. I go to z equals 24, and this time x plus y is 33. And that means we have another 7. There's no real pattern. You think, well, if it was always just one down, 13, 12, 11, then you can just add them all up. But it kind of jumps around here. There doesn't seem to be a distinct pattern. All right, no problem. Let's keep going. When z is 23, x plus y is 34. And again, you make that table, and you get 5. If you go down to z equals 22, you get x plus y is 35, and now you have only 4. When z is 21, you get x plus y is equal to 36, right? Yeah, 36. And there's only 2 in this table this time. And the last one, interestingly, is with z is 20, x plus y is 37, and you only have 1. And I might say, well, why didn't you just keep going? What about z equals 19? Why did you stop? Well, when z is 19, x plus y would be equal to 39. 38, sorry. And if x plus y is 38, then how am I going to make it so that x is less than y is less than z? If, for example, if I chose x equals 19, then y would have to be 19. And you can't have both of them equal because one has to be less. If I said, okay, fine, let me choose x equals 18. If x equals 18, then y is equal to 20. And, well, that doesn't work because y has to be less than z. You see what I mean? So once you get down to z equals 19, there's no way to make that work. So that's where we stop right here. Okay, so all we got to do now is take a look at our values and add them up. All these values that I circled, 1, 2, 4, 5, 7, 8, 10, 11, 13. And when you add up all those, you get 61. 61 for this question, and that means number 24, the answer is B. At the beginning of the winter, there were at least 66 students registered in a ski class. After the class started, 11 boys transferred into this class and 13 girls transferred out. The ratio of boys to girls in the class was then 1-to-1. Which of the following is not a possible ratio of boys to girls before the transfers? Let's discuss this now. Our total number, they're saying, has to be at least 66. And that number, of course, is the number of boys plus the number of girls. And that's got to be greater than or equal to 66 initially. Then what happens is the number of boys increases by 11 and the number of girls decreases by 13. And when it does, this ratio becomes 1-to-1. So that basically means that B plus 11 is equal to G minus 13. And if you put everything on one side, you get B is equal to G minus 24. So this is a very important formula. But we also know that B plus G has got to be greater than or equal to 66. Okay? So what we can do is what I did, is look at the answer choices and work through them. Otherwise, we'd have to make a table, and that table will go on forever. I mean, that table is going to take forever. I mean, we're going to have to put so many values in. And also, we don't know how long to keep going. Even if you say you make a table and start eliminating, and you eliminated, like, say, 3 of them, when do you stop? You have to keep going until you eliminate 4, but what if you can never eliminate the 5th one? You just keep going, or it'll be just a mess. So what we're going to do is just use the answer choices. The answer choices basically are the ratio of the boys to girls. So the ratio of the boys to girls is obviously B over G. That's all that is. At the very beginning, right? Before the transfers. Well, we figured out this nice formula. So instead of b over g, we can put g minus 24 over g. And this is something we can use. So we will use that for each of these. So let's start with 4 over 7, our first answer choice. If g minus 24 over g is 4 over 7, cross multiply, you get 7g minus 168 is 4g, and therefore 3g is equal to 168, and therefore g is equal to 56. Substitute that back into here, that value for g, and when you do, you get b is equal to 56 minus 24, which is 32. Okay, now you say, well, those work in terms of integer values, but how do I know that that's, good to keep? Like, how do I know this is a possible? Well, you have to add up b plus g, and that gives me 88. And does that satisfy this? Sure it does. So this is legitimate. This is a possible value. So this is obviously not the correct answer, because we want to find out something that does not work. That does work, we cross it off. Okay, so that's basically what we're going to do with all the answer choices. So here we go. Next answer choice is 1 over 2. So that's same thing, g over 24 over g is 1 over 2. That means 2g minus 48 is g, and therefore g is 48. And therefore, once you substitute g into there, you get, g into there, you get b is equal to 24. Now let's figure out b plus g, and that is 72. Does that satisfy this guy? And the answer is sure. So that is also possible. So we cross that out because we want the one that's not possible. All right, let's keep going. So our next one is 9 over 13. So same thing, g minus 24 over g is 9 over 13. Let's see if this works. All right, 13g when you cross multiply minus 312 is a 9g, and that means 4g is 312, and that means g is 312 divided by 4 was 78. And therefore b, if you substitute it back into there, would be 54. And therefore now we have to verify b plus g is 132. So it definitely satisfies that one. All right, great. They're making us work here. I think purposely put the answer either D or E just to make us do more algebra. All right, no problem. Well, we're down to the last two. Obviously, one of these last two has to be the answer. So, and I have a feeling that it might be E because they want us to work. But let's see. It doesn't really matter. We can do it. So the next scenario, we got g minus 24 is g, and that's 5 over 11. And we got 11g minus 24 times 11 is what? 264. And then we got 5g. So we have 6g is 264, and therefore g is 44. Substitute it back into here. And we get b is equal to 20. Now let's do that b plus g test. B plus g would be 64. Oh ho! That does not satisfy that. So D is not possible. Okay, great. That's the correct answer. And just for the sake of completion, let's just do this one, just to be complete. It won't take us that long. So by now you're an expert. G minus 24 over G is 3 over 5. So that means 5G is minus 120 is 3G. And therefore 2G is 120. And therefore G is 60. And then B would be G minus 24 would make it 36. B plus G is 96, and that satisfies that equation. So this is also possible. Therefore, in a very complete way, we have arrived at the answer, which is D for number 25.